Number 51. Here's our table. Alright, so the change in x, the delta x is 2 for each one of those entries. And there is a definite constant change in y. Constant change is always negative 25, alright? So if you add negative 25 to each y entry, you'll get the next entry, alright? So that means we have a linear function. And picking 2 points on here, I'm going to pick 0, 6 and 6, negative 69. Ooh, I picked a nasty one this time. Okay. Alright, so we've got y minus y1, the 2-point equation for a line, equals y2 minus y1 over x2 minus x1 times the quantity x minus x1. Alright, so this is x1, y1, and that's x2, y2. Alright, so you got y minus 6 equals negative 69 minus 6 over 6 minus 0 times the quantity x minus 0. And that equals negative 75 over 6 on the right side times x. Now you can move that 6, negative 6 rather, to the other side, so add 6 to both sides. You get y equals negative 75 over 6x plus 6. Alright. Or, now this can be reduced. 3 goes into both of those, so you've got negative 25 over 2 x plus 6. You can call that g of x because that's what the table calls it, g of x. There you go. Number 53. So here's the table. Note that delta x is 2. 2 plus 2 is 4. 4 plus 2 is 6. 6 plus 2 is 8. So delta x is always 2, and that's good. And then what's the change in y? It's always 20. You add 20 to each y entry, you'll get the next one. Alright, so that means you have a constant delta y over delta x. And so that's a constant slope, so we have a linear function. Okay, so I'll pick 2 points out of here. 2, negative 4. And 4, 16. Okay, you can pick any 2 you wish. So we'll use a 2-point equation for a line. Y minus y1 equals y2 minus y1 over x2 minus x1 times the quantity x minus x1. Are you getting tired of me saying that? Haha. If you've been watching all along, maybe you are, but that'll help you to memorize it. Alright, so we'll call that x1, y1 and x2, y2. And so we've got y plus 4. Y minus a negative 4 is y plus 4 equals 16 minus a negative 4 over 4 minus 2 times x minus 2. Okay, so that equals 20 over 2 times the quantity x minus 2. Of course, that equals 10. So 20 over 2, that is. 10x and then minus 20. Alright. So now I can move that 4 to the other side, subtract 4 from both sides, you get y equals 10x minus 24. Alright. Call it f of x, that's what the table calls it, and there you go, there's your linear function. Okay, number 55. If f is a linear function, f of 0.1 is 11.5, and f of 0.4 is negative 5.9. Find an equation for the function. Alright? So let me write those data down. F of 0.1 is equal to 11.5, and f of 0.4 equals negative 5.9. So in other words, x equals 0.1, y equals 11.5, and when x equals 0.4, y equals negative 5.9. Alright, so that gives us 2 points. 0.1, 11.5. And the other point, 0.4, negative 5.9. Alright. Okay, so it's a linear function, they tell us. So find the equation. We'll use the 2-point equation for a line. Y minus y1 equals y2 minus y1 over x2 minus x1 times the quantity x minus x1. Alright. So we can call that x1 y1 and x2 y2. Alright. So we've got y minus 11.5 equals negative 5.9 minus 11.5 over 0.4 minus 0.1. By the way, let me finish this. X minus 0.1. By the way, you might notice there's little dots all over my board. That's kind of leftover dirty dirty board here. Pieces of marking fluid that have dried, that haven't been erased perfectly. Well, there's a reason why mathematicians like to write a 0 when there's there's no other number in front of a decimal point. Alright, we could write 0.1 like this. A lot of people do that. 0.1. But on a board like this, you might confuse that for just a stray mark, that point. Alright? And it's easy to miss even when there's not stray marks all over your paper or board. That's easy to miss sometimes. It's a little tiny dot compared to everything else. So mathematicians put a 0 there. 0.1. Alright? So it's a good habit to get into, I think. Because there's no doubt when you see that leading 0 there, you think, well, why would they put a leading 0? Oh, there's a point after it. Ha! So yeah, that tells me I've got a decimal there. Alright, so it's a good habit to get into no matter what field you're in. You don't have to be a mathematician to use this. Okay, it'll make your work easier to read, and there will be fewer mistakes. If you're in the health profession or engineering something critical, alright, that's a good habit to do, so nobody misreads your work, alright? And that could cause some damage, who knows, or people could get hurt. So these little details make a difference, right? Math is all about little details, right? It teaches you a lot of good lessons about details. They do matter. They do matter. Yes, indeed. Okay, so negative, let's see. I put that in my calculator. I got negative 17.4. And then on the bottom, that's 0.3, 0.3, of course, times x minus 0.1. All right, so this turns out to be a nice little integer there. Put that in your calculator, you get negative 58. Divide negative 17.4 by 0.3, you'll get negative 58 x minus 0.1. So distribute that through, you get negative 58x plus 5.8. Negative times negative is positive, remember, so that's where the plus came from. And you can add 11.5 to both sides, all right? So you get y equals negative 58 x plus 17.3. Oops. There we go, 17.3. All right. Call that f of x because your table calls it, or not table, but the statement of the problem calls it f. And there you go. Number 57. Graph the function f on a domain of negative 10 to 10. So we have f of x is 2500x plus 4 grand, huh? 4,000. 2.5 grand x plus 4 grand. Okay, so that's just a joke. Don't say that to your professor, all right? Okay. What about the range? You know, they gave us a domain from negative 10 to 10. Those are your x values. So what about the y values? How are we going to scale this thing on our graphing calculator or computer? Well, put in the endpoints here. We know this is a straight line. Y equals mx plus b, right? This is a straight line, so plug in the two endpoints of the domain in this function, and that'll give you the extremes for the y values. All right, so since it is a straight line, we got f of negative 10 and then f of 10 next. All right, well, f of negative 10, plug negative 10 in there, multiply, and then add. All right, you get negative 21,000. And then take f of 10, you'll get 29,000. Okay, so those are our y values, that's our range. And you could go a little bit bigger than that. All right, you can, if you want to get the whole graph in there, make sure you get it all in there, but this will work with negative 10 to 10. Those are your x values, and negative 21,000 to 29,000. Those are the y values, all right? So you put that, that viewing window on your grapher, and you should get something like this. I put it on my computer. Here we go. See if I can get that all in there. Number 59. Table 4 shows the input P and output Q for a linear function Q. So here's the table. Think of P as being the independent variable and q as the dependent variable. P takes the place of x, q takes the place of y in the usual problems that we do. So we have parts A and B here. Part A. Fill in the missing values of the table. So how do we do that? Well, you'll note, looking back at the table, we have two missing values here, A, and there, B. But since this is a linear function that was given to us in the statement of the problem, that they told us that, then it's going to have the same slope no matter which 2 points you pick to calculate the slope. Alright, so that'll tell you how to solve this problem. Okay, so for example, if I were to pick this point, 0.5, 400, and that point, 12a, I could set it equal to the slope and then solve for a. But what is the slope? Well, you use these 2 points to calculate that because they're given in full. So that'll be easy to calculate. So what we have to do is first calculate the slope using these 2 points. Once we know what the slope is, we pick one of these 2 points and then one of these unknown points, right? So and then set it equal to the slope and then solve for the unknown. So that'll be a 2-step process because we've got 2 variables to solve for. Okay, so that's the strategy involved in solving this problem. Okay, so first of all, since q is linear, it has a constant slope m, which equals q2 minus q1 over p2 minus p1. So what I'm going to do is use the points that are given to us that are known points, 0.5, 400, and 0.8, 700. And then calculate what the slope is. So slope m is equal to 700 minus 400 over 0.8 minus 0.5. And that equals 300 over 0.3 and that equals 1,000. Okay, now that we know what the slope is, we're going to pick one of these 2 points that are known and one of the points that have an unknown in them. Put it into the slope formula and set that equal to 1,000, and then solve for the unknown. Okay, so let's use. Let's see. Let me do it over here. I'm going to use 0.5, 400. And 12a. And we're going to solve for a. So this is Q2. I have to get used to these variables now. I'm always used to y's and x's. Q2 minus Q1 over P2 minus P1. So what we've got is A minus 400 over 12 minus 0.5 is equal to the slope, which is 1,000. So we can do some arithmetic here. So we got a minus 400, and simplify the denominator a little bit, over 11.5. Equals 1,000. Multiply both sides by 11.5, so you have a minus 400 equals 11,500. Add 400 to both sides and you end up with a is equal to 11,900. Okay, now let me split this and we'll do the other one. So we're going to use same point. It doesn't matter, you could use the point that you just solved for. It doesn't matter which point that you use on this, but I'll just keep with the old point, 0.5, 400, and the other one was B, 1 million. And we're going to solve this for B. So we've got 1 million, using the formula for slope, 1 million minus 400 over B minus 0.5 equals the slope, which is 1,000. And so we've got on top 999,600, 999,600. Multiply both sides by b minus 0.5, so that'll clear the denominator. And so I'm doing both of those in one step. That equals 1,000 times b minus 0.5. Alright. And you can distribute the 1,000 through. So you've got 1,000b minus 500. Okay, so you add 500 to both sides. You get 1,100,000. So that's 1,000 and then 1,000. 1,100,000 is equal to 1,000b. And so you divide both sides by 1,000, you get b equals 1,000.1. Okay, now look out. Your book's answer has 1,001.1. All right, the book agrees with our answer for A, but not with B. The book's answer is again 1001.1. All right, that's a typo. If you plug in that value here, all right, so you go 1,000,000 minus 400. You can do this yourself. Over 1001.5 minus, or rather 1001.1 minus 0.5. All right, what does that equal? That should equal 1,000. However, when you do the computation, what you get is 999,600 over 1,000.6. Punch that into your calculator and you'll get 999.0006. All right, which is close to 1,000, but it's not quite there. Close but no cigar, as we say in the mathematical world. All right, so that is incorrect. This answer is correct. All right, you can double check it by plugging it into B here and then doing the computations, and you will get 1,000 as a result. Okay, so there you go for part A. And now I'm going to have to do a little quick erasing here, and we'll get to part B. Okay, here we go with part B. It says write the linear function q. Alright, so what you do is you use 2 points, and you can use a 2-point equation for a line. Okay, so you can use any 2 points. I'll just use the ones that they've already supplied us. 0.5, 400, and 0.8700. Alright, so I'm going to use x's and y's because I'm used to that. We'll go back to p's and q's after we're done. Alright, so we've got y minus y1 equals y2 minus y1 over x2 minus x1 times the quantity x minus x1. Alright, so we've got y minus 400 is equal to 700 minus 400 over 0.8 minus 0.5 times x minus 0.5. Well, you know, silly me, I could just use 1,000 because we already know what that is. I'm so used to just plugging and chugging in a formula that it just kind of becomes second nature. Alright, so we'll just change that to 1,000 next step. So we've got 1,000 x minus 0.5. Alright, distribute, you've got 1,000x minus 500. And then add 400, so you've got y equals 1000x minus 100. Adding 400 to both sides. Okay. Going back to p's and q's, p is used instead of x, q for y. So we've got a function q of p instead of y of x, alright, equals 1000 p minus 100. Alright. Okay, number 61. It says graph the linear function f on a domain of negative 0.1 to 0.1 for the function whose slope is 75 and y-intercept is negative 22.5. Label the points for the input values of negative 0.1 and 0.1. In other words, what they want you to do on that last sentence is find f of negative 0.1 and f of 0.1 and label those 2 points or mark those 2 points on on your graph. Okay, so that's what we're going to do. So the y-intercept has an x-coordinate of 0, so that's 0, negative 22.5. Okay, that's where the line meets the y-axis, and where the line touches the y-axis, the x-coordinate will always be 0. Okay, and similarly for the x-intercept, wherever you have an x-intercept, the y-coordinate for any point on the x-intercept, or for any x-intercept that is, the y-coordinate will be 0. Alright, so using the point slope equation for a line, that's y minus y1 equals slope m times the quantity x minus x1. We only have 1 point and they gave us the slope, so we're using point slope equation. That's a little different from the 2-point equation. in a 2-point, you're using 2 points, you're not given a slope. And you put the formula for the slope in place of m in the point slope equation here. And then you just substitute the values. Alright? So we've got, let's see, y minus negative 22.5, that's your y1, equals the slope, which was negative which was 75, not negative 22.5. Okay, 75. And then you've got x minus x1. x1 is 0, so x minus 0. Alright? So this is y plus 22.5 equals 75x. Subtract 22.5 from both sides, you get y equals 75x minus 22.5, or call it f of x, 75x minus 22.5. Alright. Now what we need are is the viewing window. We're already given the domain. Maybe we should go a little bit outside the domain they gave us, because they want us to mark the points with input values of negative 0.1 and 0.1, and you'll notice those are the two endpoints on the domain they gave us. So the points are going to lie on the very boundaries of your viewing window, which, depending on your calculator or whatever you're using, may not be very apparent on the screen. So let's expand it a little bit. Let's say the viewing window, I'll put it up here, the viewing window, the VW, goes from negative 0.12 to 0.12, that's your x coordinates. This is a judgment call as to how much wider you want to make this. And now, what about the y coordinates? Alright, well, you need the function values for these two x coordinates. Alright, so that'll give you the y values. So what's f of negative 0.12? That equals 75 times negative 0.12 minus 22.5, and that equals negative 31.5. And we also need f of 0.12. So plug that in to x right there. And what you end up with is negative 13.5. So we've got negative 31 to 31.5 rather to negative 13.5 for the y values on your viewing window. So that's what you can set on your computer. And then you want to label the points, alright, for when x equals negative 0.1 and 0.1. Label that on your graph. Alright, so here we go. Here's what my computer spat out for us, and I've labeled the 2 points. Let's see if you can see these. Alright. Now the computer slid the, you can see the x-axis is below. Actually it's above, over this area here. Should be above, alright, but the computer liked to draw it like this. Alright, so actually it should look like this, your axes. Alright, here's your y-axis, here's your x-axis. And there's quite a bit of distance going down on the x, or rather the y-axis, as you can see. This one starts at -14 and goes down, so it's missing a lot up above. So you can draw a break like that, and then you've got your line, which looks something like this. All right, this little zigzag here is used in drafting, general drafting, which indicates a break in the line. Okay, so that's been used for quite a long time in drafting. All right, so there you go. That should cover that problem. Okay, number 63. Find the value of x of a linear function, or if a linear function goes through the following points and has the following slope. We've got the points, let me write these down. x2, -4, 6, and the slope m equals 3. Alright, so they gave us a slope, and that's a clue to use a slope formula to calculate x. This is kind of like what we did in the previous problem, finding a and b in that one problem. Okay, so let's use a slope formula with these 2 points. Alright, so 3 is equal to y2 minus y1 over x2 minus x1. I'll set it like that. And now just plug in the coordinates. You've got 6 minus 2 over -4 minus x equals 3. Alright. So now you clear the fraction by multiplying both sides by -4 minus x. So you've got 6 minus 2 on top is 4 over -4 minus x times -4 minus x equals 3 times -4 minus x. Alright, multiply both sides by -4 minus x. Cancel, cancel. Oh, don't you love canceling? Yeah, 4 equals, and then distribute that through, -12 minus 3x. Solve that for x. Alright, so you've got, you can move this to this side. 3x is equal to -12 minus 4, or -16. So x, divide both sides by 3, x is equal to -16 thirds. Alright. So that takes care of the x. Number 65. Find the equation of the line that passes through the following points. Oh my gosh, there are letters in here. Oh, no numbers at all. Oh, there's one number. Hey, thank you. Okay, we've got the points A, B, and A, B plus 1. Will we ever solve this? We'll see. We'll see. All right. Well, it turns out this is pretty easy. Haha. They got you running scared, huh? But hey, they don't have any weapons really. They just have a bark worse than their bite on this one. Okay. You've got two distinct points here. They're different points rather, but they have the same x-coordinates, right? They have the same x-coordinate, that's an A. They have the same x-coordinate, different y-coordinates. What does that tell you? Aha. If you were to graph this, I don't know where A is, let's just pick somewhere on the x-axis for A. Could be anything, whatever it is. Let's say this is A on the x-axis. These 2 points lie on a straight line, and they have the same x-coordinate. And so that means you've got 2 points lying on a line that will go through x equals A, like that. Alright. Now I don't know exactly where B is or whatever, it doesn't matter. Just to illustrate the problem. Alright, you've got 2 points that lie on the line x equals A. That's what the line is. It's a vertical line, x equals A. Okay. So, in other words, the x-coordinate of every point on this line equals A. Alright, so these 2 points are on that line. So there you go. Okay. So this is a vertical line with equation x equals A. Alright. It's a similar situation with a horizontal line, but the y-coordinate in that case will always be the same. Okay, y equals B if you want to say, or something like that. Okay. So vertical lines are kind of a class unto themselves, right? You've got no slope. If you try to calculate the slope on this, you'll be dividing by 0, which you can't do. It doesn't exist. The slope doesn't exist. That's different from saying the slope is 0. A line with 0 slope is a horizontal line. Okay, 0 slope is not the same as saying no slope. When you say no slope, you mean the slope doesn't exist. It's not a real number. All right. So there's a difference between the two, and I can understand where people get confused because from very early age they associate 0 with nothing. So when you say no slope, you think nothing and you think 0, right? But in mathematics it's a little more precise. Okay, there you go. Alright, number 67. Find the equation of the line that passes through the following points. Letters again. A0 and CD. Alright. Well, after the previous problem, I think we can handle the letters. A0 and CD. Okay. That's why we have algebra, so we can play with letters, right? Alright. There's more to it than that, but anyway, we've got 2 points, so I'm going to use the 2-point equation for a line. Y minus y1 equals y2 minus y1 over x2 minus x1 times the quantity x minus x1. Alright, so plugging in the numbers, this is going to be x1, y1, x2, y2. So you got y minus 0 equals d minus 0 over c minus a times x minus a. Alright, so y, it's just y on the left side, equals d over c minus a. And let's distribute this through. That's going to hit the x, so that's x. And then you've got the minus. And then you've got a times d on top. Think of that as a over 1 times d over c minus a. Alright, and so you're going to get the numerators ad on top over c minus a in the denominator. Alright, so we've got, well, that's basically all there is to it. Alright, what does that mean? Well, If you have definite numbers for A, C, and D, then this will give you a formula for the equation of the line that joins those 2 points. All right. So, and you're thinking, why would I need something like that? Well, you may not ever need something like that, but then again, you're getting used to working with letters instead of numbers. That's one of the big things about algebra. All right. And algebra symbolizes a lot of things, which gives it a great power. Okay, take my word for it, you'll see. Okay, number 69. A gym membership with 2 personal training sessions costs $125, while gym membership with 5 personal training sessions costs $260. What is cost per session? Okay, so be careful here. Don't just divide the cost by number of sessions. You'll come up with different results. The problem is most businesses will give you a bulk rate, right? If you order more, you'll get a discount. Okay, so what you do is you use a slope formula with these 2 numbers, these 2 monetary values. You've got 260 minus $125 over 5 minus 2. Alright, so that's the change in cost over the change in sessions equals $135 over 3, which equals $45 per session. Alright. Now if, again, if you just divide, do a simple division, 125 over 2, you're going to get 62.5. And if you divide 260 by 5, you get 52. So there's different cost per session depending on what figure you use. All right. And if you do it that way, what you're assuming is y over x equals some constant. And then that means for x plus 1 sessions, let's say, x stands for sessions, y stands for the cost. So if you have x plus 1 sessions, if you keep up with this assumption, what you have is y equals, we'll put in x plus 1 down here, y equals k times the quantity x plus 1. So in other words, put x plus 1 here and then multiply both sides by x plus 1, you get this. And that equals kx plus k. Now over here, you've got y equals kx. Alright? But here you have kx plus k, so you just add another k dollars for each additional lesson. But again, most businesses offer discounts if you get more sessions. All right, so this is really too simple of a way to do it. Okay, all right. Okay, number 71. A phone company charges for service according to the formula C of n equals 24 plus 0.1 n, where n is the number of minutes talked and C of n is the monthly charge in dollars. Find and interpret the rate of change and initial value. Alright, the rate of change is simply the slope of the line, okay? In this problem, the rate of change is the slope, okay? In fact, when you get into calculus, you'll talk a lot about rates of change. How fast is a function changing? All right, and that also happens to be a slope, but it's defined in a more sophisticated way to deal with general curves, all right, using something called limits, but we won't go there. Initial value would be when n equals 0, what's c? Okay, that's initial value. What's the starting point, in other words? You'll hear a lot about initial values, especially in differential equations. If you continue on in math, which I hope you do, you can take differential equations after calculus sequence, and you'll see lots of initial value problems, okay? Trust me, I've been there. Yeah, that's a long time ago, though, for me. All right. So the rate of change, what's that? That's the slope. If you think about it, the slope of a line will tell you how fast it's changing. If it's just a small slope, it's like a hill, right? Going up a hill. The rate of change of altitude with horizontal distance is small, so the slope is not very much, right? So the rate of change is not very much, but if you go up a steeper hill, start climbing up that bad boy, right, the rate of change is greater, right? You got a greater change in altitude with horizontal distance, so the rate of change is higher for that one. Okay, so the slope on this, well, what is, well, let me write the function here. C of n equals 24 plus 0.1n. The slope is right next to the variable, so it's 0.1, or 1/10. Okay, so that means that the monthly charge increases. Why increases? Because it's positive. If it were negative, if that was a minus there, you'd say the monthly charge would decrease, all right? But here it's positive, so the monthly charge increases by $0.1 per minute. Okay? So again, we're talking about the cost or the charge in dollars, and n represents the number of minutes, so that's where we get our units. So the cost is increasing by $0.1 per minute. Okay, $0.1 is 10 cents, so that's 10 cents per minute. Okay. And that's for each additional minute talked, all right? So the initial value is equal to C of 0. So when n equals 0, that equals 24, right? Let n equal 0 in the formula, and you get just 24. So in other words, if you have n being the number of minutes that you talk being 0, if you don't talk at all, you're still going to get charged $24. That's your initial value, okay? Why are you getting charged when you're not even talking? Well, upkeep of their equipment, I guess, paying their employees, right? Keeping your name in their computer, taking up space, whatever, all right? That's their overhead, okay? That's what they, you know, that covers their costs even if they don't put out any work. So they're, you know, they have to pay for their electricity and all that stuff. They have bills coming in even if they're not working. So there's your initial value. So that's another word for that would be the base charge. Number 73. A city's population in the year 1960 was 287,500. In 1989, the population was 275,900. Compute the rate of growth of the population and make a statement about the population rate of change in people per year. Okay, so the rate of growth would be the change in population over the change in time. All right. So that would be 275,900 minus 287,500 By the way, are we expecting a positive or a negative rate of growth? Okay, if you look in 1960, it was a little over 287,000, and in 1989, later, it went down roughly 276,000. All right, so we're expecting a negative result, a negative rate of growth. All right. And so far we don't see that. This is going to, oh yeah, we do. This is a negative on top, isn't it? Yeah, so that is something we would expect. Okay, so we don't have to panic about, oh, we're doing something wrong. No, we're expecting something negative here. 1989 minus 1960. All right, so this population belongs to this year, and this population belongs to that year. All right, so that's equal to negative 11,600 over 29. And that's equal to negative 400. And the units are people and years, so people per year. Alright, so in other words, since it's negative, the city is losing people at the rate of 400 per year between 1960 and 1989. Now, whether it's the same figure before that date or after is something that remains to be determined. All right, but for between those two dates, we can say that this is the definite figure. All right, they're losing 400 people per year. Okay. Whoa, guess what? We're on the last problem. Haha. How about that? All right. Get ready to take a break. Okay, let's do this. Suppose that average annual income in dollars for the years 1990 through 1999 is given by the linear function I of x equals 1054x plus 23,286, where x is the number of years after 1990. So which of the following interprets the slope in the context of the problem? Okay, well, let's go through each choice. I'm going to refer you to your books to see the choices, and I'll read them to you as well. So even if you don't have a book, you can do these, right? So part A, or rather choice A. As of 1990, average annual income was 23,286. Let me write the formula down before I answer this, just so that's fresh in our minds. I of x is 1054x plus 23,286. Okay, so as of choice A, as of 1990, average annual income was 23,286. You'll note that that figure is the initial value. When x equals 0, that's what you get. That's your initial value. Okay, and so it is true. It is the initial value, and the choice is true, but that doesn't explain or interpret the slope in the context of the problem, which is what they want us to do. So we can't use A, even though it's true. Part B, or choice B, in the 10-year period from 1990 to 1999, average annual income increased by a total of $1,054. Well, that's not true. Okay, what was the average annual increase? You can calculate that. That would be I of 10, in other words, 10 years after 1990, minus I of 0, the initial value. That'll tell you the increase, all right? And or the average annual income increased by that total of 1054. Okay, so that's actually 10,540. If you plug those in and calculate it, you'll get 10,540. Okay, so again on choice B, the increase was 10,540. All right, and let's see what's next. What about part C, or choice C? Each year in the decade of the 1990s, average annual income increased by $1,054. Yeah, that's correct. That, in fact, is the slope. All right. So that's what we're looking for here. Each year in the decade of the 90s, average annual income increased by 1,054. So that's the correct interpretation of the slope in this context. And let's look at choice D. The average annual income rose to a level of $23,286 by the end of 1999. And this again is not the case. All right. So you can go back and see part or choice B on that one and think about it. All right. So there's the answer is C on this one. All right. So that takes care of 2.1, and you guys can now take a breather, all right, as can I. And we will get back to you later. Go get your adult beverage or your non-adult beverage. Take life easy for a while, and put your feet up, watch some TV, whatever you want to do, all right? And we will see you in the next section. You. All right, don't touch that dial. We'll be back. All right.